Hi everyone, today we're discussing two problems from potentiometry. The first problem that we have is 18-22. The solubility constant, or the constant for thallium sulfide is 6 times 10 raised to negative 22. Calculating the E standard cell potential for the process of the reaction given below, which is right here, given right here. And to do this, we will first need to know what is the E standard cell potential of the half cell reaction, which we will be using the thallium, the half cell reaction of thallium. And another thing that we need to learn and we need to apply is the solving for KSP expression, which we have done right here, showing us that this expression equates to the KSP, which is given. Next is, in this problem, we will be using the Nernst equation, and the Nernst equation is as follows. E is equals to E standard cell potential minus 0.0592 over N log Q. And for us to solve the E standard cell potential of the given process, we have then to input the values that we have and solve, which is E is equals to negative 0.336 minus 0.0592 over 2 times log 1 over thallium plus raised to 2. Now, thallium, 1 over thallium, we do not have the concentration of 1 over thallium. However, if we rearrange the KSP expression, we can then get the S sulfate 2 minus over KSP, which will change our equation into negative 0.336 minus 0.0592 over 2 times log sulfate 2 minus over KSP. Now, assuming that sulfate 2 minus is equals to 1, we can then say that the E is equals to the E standard cell potential of the given process that we have. Now that we have all the values that we need, we only have then to apply the values, or to input the values rather. So it will be E is equals to negative 0.36 minus 0.0592 over 2 times log 1 over 6 times 10 raised to negative 22. And if we input this in the calculator, it will give us 0.0592 over 2 log over 6 times 10 getting 22. It will give us a voltage of negative 0.964166723, or just to summarize, it will give us negative 0.96 voltage. Now, this method can be used if the question is asking for E standard cell potential, and it is important, very important, that we have to know what is or what half cell potential to use, or what is an E indicator, and how to formulate or create a KSP expression so that we can use this method and these assumptions in solving these kinds of problems. Now, moving on to the next problem we have is 21-16, which has 4 different problems, which we can then answer part by part as to emphasize how to create or to solve these questions. The first question is another E standard cell potential, which is the process of which will be doing the process of this now. Now, to solve this problem, we have then first to create a KSP expression, which is right here above. And this value right here, just to jump further, is the value of the E standard cell potential of the E indicator of the half cell reaction. Just to clarify things, it's not specified. And as I have done earlier, we will then use the Nernst equation, which is as follows. And then we have to input the values that we already have, which is the E standard cell potential of the reaction of the E indicator, 0.0592 over 2, which is 2 meaning n, and times log of 1 over Pb2 plus. Now, as is done from the previous problem, we can then equate Pb2 plus to equals to iodine raised to negative 2 over Ksp by manipulating the Ksp expression. So, just to demonstrate, let's see. I Ksp should wait a second. Iodine will equals to negative 2 over Ksp Pb2 plus. However, the equation is 1 over the equation is Pb2 plus, and it will equate to I negative 2 over Ksp. It is from Pb2 plus equals to Ksp over I2, and just inverting this expression just to have the 1 over Pb2 plus, then we have the expression in the equation, just right here. It will be resulting to right here. Now that, like the other problem or the problem earlier, we have to assume, or we assume that I is equals to 1, or its concentration is equals to 1, and it will equate to the E standard cell potential of the process. So now that we have all the values that we need, we just need to input this into the calculator. Now the E standard cell potential is equals to negative 0.126, negative 0.126 minus 0.0592 over 2 log 1 over KSP, which is 7.9 times 10 is to negative 9, which will give us a voltage of negative 0.365830, or just to round it up, it will be negative 0.366 voltage. Now, the first part of the problem is done. Let's move on to the shorthand notation. Now, first, there is a formula as to know what is the shorthand notation, but first we have to know what the problem is. Use the shorthand notation to describe a cell consisting of a saturated calomel reference electrode and a LED indicator electrode that could be used for measurement of pi I. So, following the equation, which is E reference, then the lines right here, and this is the concentration, then another line, E indicator. As mentioned in the previous problem, this will represent calomel, the reference, and this will be the LED indicator, and this will be the saturated or the concentration of the process. And by following that formula, we can then arrive to this kind of shorthand notation. Now, moving on to the third part of the problem. Generate an equation that relates the potential of this cell to pi I. To do this, first, we have to know the relationship of the potential, which is E cell is equals to E right minus E left. In this instant, E right is lead iodide minus E SCE, which is the calomel. Now that we have this base equation, is just then to input the problems of this equation as to solve the pi I or the formula for pi I. Now, in solving this, we have negative 0.366 minus 0.0592 over 2 log I raised to negative 2 minus e negative minus 0.244. Now, to get this equation, or to get this resulting numbers, you have to understand the property of the logarithmic, because we will be using it. Because of the negative 2 here, in logarithmic, we can bring it down to its side, which will then cancel out the negative here, will turn to positive. That's how we, then because of the 2 beside the log, it will then cancel 2 here. So, and these 2 will just add up together. Now, this will then result into the negative 0.610, which is the addition of these 2. And then this is the result of the cancellation of the signs by bringing down negative 2 from I, which is the log of I is equals to pi I. Now, we just have to rearrange our equation as the result for the equation of pi I is equals to E cell plus 0.10, 0.0592. Now, moving on to the last equation. In the last equation, calculate pi I if this cell has a potential of negative 0.402 voltage. Now this is very easy as we just have to input the problem that was done earlier. So just input these values in the equation 0.402, 0.0592 plus 0.610 will give us 3.51. I hope that this video is helpful in understanding some of the properties or some of the problems and what to do in potentiometry. And that's about it. Thank you.